This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 204. Hopefully your summer is coming to a successful and restful ending. The title of today's presentation is Forecasting Smoke and Dust by NOAA's Experimental Rapid Refresh Forecasting System model. I'm pleased to have Ravan Ahmadov from NOAA's Global Systems Laboratory with us. The discussion following Dr. Ahmadov's presentation will come from Todd Lindley, the Science and Operations Officer at the National Weather Service Weather Forecast Office in Norman, Oklahoma. I also want to acknowledge Todd as the 2025 recipient of the American Meteorological Forecaster Award for an exceptional specific prediction. I believe he shares this award with NWS Norman, Amarillo, the Oklahoma Forestry Service, and Texas A&M Forest Service due to collaborative issuance of life-saving fire warnings and wind shift forecasts during the Texas Panhandle and Western Oklahoma fires earlier this year. Todd, congratulations. Just a few other reminders before we get started. As you just heard, that this session is being recorded. Please mute your microphone and turn off your webcam if you are not the presenter and you are not asking a question. There will be time for Q&A after the presentation. We ask that you post your questions in the chat or post that you would like to ask a question in the chat, and we'll field them in the order they are asked. We also, if you have not signed in with your full name, we also ask that you specify your full name when asking a question in the chat. Perhaps you're logged in with an office account. We're also looking for future presenters. There is a link in the chat. Perhaps you have a presentation coming up at the National Weather Association annual meeting on a satellite-related topic, or maybe you're just using satellite data. We'd love to incorporate that into the Satellite Book Club following that meeting or any meeting that you have coming up. The training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Russ Van Til with the Office of the Chief Learning Officer can help with that. I'd like to thank the GOES program, the JPSS program, the Office of the Chief Learning Officer, our presenter, facilitator, and all of you for being with us today. Special thanks to our TowerS team members, Kushad Bowman and Emily Maddox, who work the Satellite Book Club behind the scenes each and every week. It's much appreciated. Without further ado, let me formally introduce Dr. Ravan Ahmadov, a physical scientist at NOAA's Global Systems Laboratory. He is leading the atmospheric composition branch at the Earth Prediction Advancement Division at GSL. He led the development of NOAA's HRRR-Smoke model, and over the last few years, Dr. Ahmadov's team, in collaboration with other NOAA laboratories, has been working on the development of fire weather and smoke modeling capabilities in NOAA's experimental RRFS model. Ravan, we're glad to have you back at the Satellite Book Club today.
Thank you. Can you hear me well?
Perfectly, thank you.
Great. Yeah, thank you for the introduction. It's great to be here, at least virtually. I see some familiar names, and I'm excited to have this opportunity to present our new model, still experimental, but with new capabilities, with a lot of improvements compared to our previous HRRR-Smoke model, to the forecasters and other potential users. And here's my email address. Feel free to contact me if you have questions or any other collaboration for some like opportunities. We are always glad to receive feedback from the users. That's how the HRRR-Smoke model became operational and now is widely used by the forecasters and public. I also want to acknowledge many colleagues here at GSL and other NOAA laboratories, including NESDIS. We have been working closely with the NESDIS colleagues project. So today I'm going to talk about this rapid refresh forecasting system. This is an experimental model. Probably some of you are familiar with this model. It is a new or next generation NWP model that's NOAA, our lab, in collaboration with EMC and other laboratories have been developing. And but before talking about the RRFS model, I want to also remind you, next slide, please. Yeah, I want to just briefly remind you where all this has started. As I said earlier, we developed this currently operational HRRR-Smoke model, and this is just a brief overview of these existing operational smoke forecast models at NCEP. So how these models are working, basically, as some of you probably are familiar with RAP and rapid refresh and high resolution rapid refresh models. These are currently operational NWP models. There's 3 models depending on the domain. RAP is on a coarser resolution, 13 kilometer resolution, but it covers a very large area, as you can see on this map. The entire North and Central Americas, even parts of Russia and South America, on Europe, but here we are taking advantage of the RAP model to provide boundary conditions of smoke to the HRRR-Smoke models for both Alaska and the CONUS regions. And why this is important, for example, when there are fires in Canada or Central America, RAP model provides these boundary conditions to these high resolution 3 kilometer HRRR models. And as you know, the satellite fire radiative power, also the satellite fire detections have been widely used for both in models and also by the forecasters. Here we ingest FRP data from 2 MODIS and 2 VIIRS satellites. So only polar orbiting satellite data are utilized in this modeling system. And HRRR-Smoke model is able to capture the mesoscale flows and smoke transport in complex terrain, which is very important, as a lot of wildfires occur in the western US, where in the mountainous region. And another important feature of these models I want to highlight here is smoke feedback on radiation. So solar radiation and visibility are included in these models. I believe this is only NWP model currently operational at NOAA and in many of the world NWP centers, which has this interactive areas of feedback on meteorology. And this rapid refresh models, since there's this hourly cycling, this is how these models are designed. Basically, every hour a new forecast starts by assimilating the latest weather observations, for example, radio soundings and surface weather observations. And this also gives us advantage to improve our smoke forecasting capabilities, because fires, they can start anytime. They can flare up any time of the day or die down, and it is important to bring this information into the models in timely manner. So this hourly refresh cycle helps with that. Next slide, please. But then a few years ago, NOAA decided to transition to a new die core, so-called finite volume cube sphere dynamical core, FV3. And currently, the GFS model actually is based on this die core. So as you can see on this slide, 3 these three models are being replaced by one single model or single domain at 3 kilometer resolution, but covering a very large area. Again, somewhat similar to the RAP domain, the entire North and Central Americas and some surrounding areas. It's obvious this provides us huge advantages. Instead of having three models, again, at high resolution, we can cover this entire region. If there's a fire in Canada or Central America at 3 kilometer resolution, these fires will be simulated, and the smoke transport will be forecasted from these fires within this domain. Next slide, please. So which satellite data we use in this new model? There's a new product developed by NESDIS. It's called RAVE, which stands for Regional ABI and VIIRS fire emissions. This diagram is from the paper from the RAVE team, which describes this the design of this emission inventory. Basically, the VIIRS satellite data and also GOES 16 and 17 ABI fire-rated power data are processed and blended and generated and regraded at 3 kilometer resolution, hourly time frequency, which we ingest into our model. I want to clarify one detail. We estimate smoke emissions ourselves, but we use the fire radiative power and fire radiative energy, hourly fire radiative energy data from RAVE. And we used to get this question frequently, when are we going to ingest the GOES data into HRRR-Smoke? So that's as you see here in this new model, we are ingesting the GOES data, and we see advantages, definitely improvements because of this new data set. Next slide, please. So we estimate smoke emissions, and a lot of information is used in addition to the satellite data, like land use type, and also weather conditions to predict the fire emissions. I will talk about that a little bit. And this is one of the, like, a snapshot of the smoke emissions from the RRFS smoke model for this year in end of May, when there were wildfires, actually a lot of wildfires in Central America, and also some wildfires in Canada. Back then, the fires in Canada, there weren't many. Later in the season, as you know, there were a lot of wildfires in Canada. So, what are the main features of this new model? As I said earlier, 3 kilometer horizontal resolution covering a very large area. 65 vertical layers compared to 50 in HRRR-Smoke. And just to clarify, when we say HRRR or HRRR-Smoke, these are the same models. It's just depending on which context we describe these models, like weather forecast or in terms of smoke forecast. And I'm not going to read all this, but a few things I want to highlight. HRRR-Smoke forecast length, the maximum was 48 hours, 4 times a day. For this model, is 60 hours, 4 times a day. And another big, more prominent new feature, new capability in this model is this new fire weather index, hourly wildfire potential, so which I'm going to describe in my talk. And this is in the bottom, you can see this URL. This is a web page maintained by our lab, which displays the experimental RRFS smoke and dust plots, different fields from this model. Next slide, please. So this is a snapshot of near surface smoke forecast for the same time period back in May, when there were a lot of wildfires in Central America and some fires in the western part of Canada. And from my experience, I can say every year during spring time, we see these fires, active fire season in Central America. But I think it's, I can say, again, based on my experience since 2016, when we started HRRR-Smoke, probably this was the worst fire season in Central America. And actually, smoke affected air quality in southern Texas and Louisiana, Florida, quite a bit during this time period. Next slide, please. This vertically integrated smoke is again the total smoke amount within the atmospheric column. In the model, this is from the surface all up to 20 kilometers, and this has the impact on so the radiation reaching the surface, cloud formation can affect, or you can also see like this spectacular sunrise or sunsets because of this smoke which is not just in boundary layer, or oftentimes a lot of smoke in the free troposphere. Next slide, please. Yeah, so this is some verification, and we have actually a near real-time verification. So we are conducting continuous verification of this new model, and also we compare it with the HRRR-Smoke model. This is one of the examples, the model evaluation for Corpus Christi, Texas. Again, for the same time period, 26th of May, when you can see upper left on the upper left panel, this black line is PM 2.5 for 2 days, hourly PM 2.5 measured by an AirNow site. As you can see, smoke reached 60-70 micrograms during some hours, so air quality was definitely pretty bad. And the red lines are RRFS smoke forecasts for different cycles. As I said earlier, there's 4 cycles which go longer, others go out to 18 hours, but 4 go out to 60 hours. Upper right panel is visibility, and visibility obviously is degraded dramatically due to the smoke impact. Smoke combined with humidity can really affect visibility quite a bit. We may get even sometimes the super fog events. So the black line is the measurements, the red is RFS smoke, the blue line is HRRR-Smoke. So you can see on the left, upper left, HRRR-Smoke, this blue lines, again, different HRRR-Smoke cycles, forecast cycles. And there are reasons why HRRR-Smoke underestimates, as I said earlier, actually HRRR doesn't cover Central America, so it uses boundary conditions and RAP model due to its resolution, and due to other reasons doesn't capture those fires very well. So then one of the obvious clear examples of the model improvement. Low left on the low left panel shows the temperature forecast. Again, the black line is the measurement. So obviously this aerosol loading, high aerosol loading reduces the solar radiation reaching the surface, thus affecting the temperature, air temperature. Next slide. Yeah, as I said earlier, actually, we have the name of this model, we say RRFS-ST, which means RRFS smoke and dust. This is a new capability, like the HRRR model doesn't include any dust forecasting capability. So we include actually 2 dust traces, one fine dust less than 2.5 micron, another is coarse. So coarse dust usually, I mean, a lot of mass is released into the atmosphere, but a lot of coarse dust falls quickly, fine dust can travel longer distances. So both have impact on air quality, especially fine dust can go to human lung, and also visibility and weather in general. So this is one of the examples of our experimental dust forecasts back in September last year, when there were some dust events in the southwestern part of the US. And dust is also associated oftentimes not just with wind, also drought. Next slide, please. I'm not sure, I see something in the chat. If there's any quick urgent question, please let me know. How we evaluate our dust forecasts. This is another dust forecast. This is more much like strong, very like significant dust outbreak. And back in February last year in New Mexico, and we use PM10 measurements, PM2.5 and also PM10, special PM10, but the PM10 measurements, the PM10 network is very sparse. So how we complement these data sets, we leverage the satellite data. On the right panel, you can see what you see is GOES 16 multispectral imagery with dust, so-called Deborah algorithm. I believe it was developed by CIRA. And this is very useful, very helpful to just have quick evaluation. And yeah, this is just of the CONUS domain for visualization purpose, but again, the domain is RRFS. We have dust capability with the entire RRFS domain. Next slide, please. So I mentioned this new wildfire potential. So what's this product? And there are other fire weather indices out there widely used by the forecasters. So what's this specific? What's different here? First of all, the capability to simulate fire weather depends on capturing mesoscale phenomena. Convection allowing models like HRRR and RRFS with 3-kilometer grid spacing are capable of representing deep convective storms and their outflows, as well as terrain-induced circulations. So hourly wildfire potential is a new diagnostic product based on hourly air temperature, humidity, wind gust potential, soil moisture, and also solar radiation. And these maps, this is one of the examples back in June when high fire danger was expected according to the model over almost entire western US. Again, due to high wind, dry conditions. So why we developed two main objectives here. One is to help forecasters, to like anticipate, for example, how weather conditions, sometimes rapidly evolving, like convective outflow, how those conditions may affect fire behavior. Second is we use this index to modulate fire emissions, because it is very hard to predict fire emissions into the future. So how we do this? Next slide, please. I'm going to show one example for the Cameron Peak Fire, wildfire burning back in summer 2020 in northern part of Colorado. The next slide, please. So this is a busy slide. So what's this time series? What are these time series? The dashed black line is the satellite FRP hourly fire radiative power from the RAVE product, and the RAVE is this blended dataset based on VIIRS and GOES detections. So what was happening, as you see on the left the axis, is you can see the scale, the magnitude of the FRP reaching about 20,000 megawatts for the entire communal fire area. The fire actually started earlier in August, but then in September this fire again started flaring up because of changing weather conditions. And here I describe, you can see these arrows, these different kind of conditions, how it started warming up, and then it got windy, and then next day it's very windy. And this shows how, again, FRP was increasing, but then snowstorm arrived and the fire was almost like it was, and almost ended. There are a lot of uncertainties in FRP detection, for example, due to cloudiness. I won't go into all those details, but again, this is our like first order approach to use this index, HWP to predict fire radiative power, which is the red line. And as you can see, our method is able to capture this this evolution of the fire intensity. And again, we use this method in our model to predict fire emissions. So like in HRRR-Smoke, it's based on persistence and climatological diurnal cycles. But obviously persistence doesn't work always. And there are other factors also driving the fire intensity. So next slide. Yeah, so here I describe them briefly, and such as fuel density, fuel moisture, dead versus live fuel, topography, firefighting operations, of course. So all this need to be taken into account, and it's extremely hard to factor all these processes in our models, numerical models. So next slide, please. Yeah, because of time, so I want to wrap up. So this is our website, and just a snapshot. On the left, this column, you can see which fields we display, and there are more fields actually now on the website you can find. And again, feel free to reach out if you have questions about this website. Next slide, please. So here I want to mention a few things, since a lot of forecasters are in this call. There are limitations of the input data and also the models that need to be considered in utilizing the smoke model forecast products. And this can also go it's true for dust forecasts. First of all, fire detections, and fire detections can be missed due to clouds or dense smoke. And forecasting the diurnal cycle of the fire emissions is extremely hard. I already discussed this. Sometimes we expect fire will flare up, it doesn't, or sometimes vice versa, it will die down, but actually it flares up. And again, for the model, our data set, we don't have information, for example, about dead fuel in a given region where there's a fire. And the inaccuracies in weather forecasting, either RRFS or HRRR or any other model like wind speed or boundary layer height or like extreme weather like thunderstorms, etc., which all impact fire behavior and also smoke transport. So these uncertainties need to be taken into account when these smoke forecast products are used in the field. And also please note, RFS smoke dust or even HRRR-Smoke does not include anthropogenic pollution or chemistry of the aerosols. So this is very simplified, extremely simplified air quality model. So in summary, I want to emphasize that the local weather forecast offices, IMETs, air resource advisors are critical in interpreting the model forecasts. And thank you for your attention.
Thank you, Ravan, for that excellent presentation. Let's see, we do have some conversation starting in the chat room already. Before we get to that, I would just like to further encourage attendees to please stay for our question and answer session and discussion following Ravan's excellent presentation. And especially if you're from a National Weather Service field office or regional headquarters, please feel free to jump in and ask Ravan these questions. It's a great opportunity to go straight to the source and ask, and it looks like we've got a good head start on that. Like I said, I'd also like to encourage everyone to activate or turn your cameras over to active cameras. That's found in the upper center part of your GoToMeeting window there. That way the camera will turn on to you when if you begin to speak, and we would appreciate that. Also, 1 week from today, on Thursday, September the 5th at high noon Eastern Time, we'll have Dr. Mitch Goldberg, who is a research scientist from City College of New York, and he will evaluate tropics data. And also, please do contact Kashad Bowman or Emily Maddox if you have any questions about the Satellite Book Club or for configuration of satellite products. And with that, we'll dive into some of the discussion that we already have in chat. Feel free to indicate in chat if you'd like to speak verbally. Since we have a list here going already, I'll just jump in and we'll go straight to Jonathan Case's question. He says, can you tell us why the RRFS, or as we call in operations, the Rufus, SD simulated PM 2.5 so much better than the HRRR-Smoke this spring?
Yeah, I alluded to that a little bit. So first of all, the HRRR-Smoke domain is much smaller than RFS. So if there are fires in Canada or Central America, HRRR-Smoke relies on this RAVE-Smoke model, which is at coarser resolution, 13.5 kilometer resolution. That's number one. But second, maybe more importantly, we have learned a lot based on our experience with HRRR-Smoke and ongoing research here. So we have made a lot of improvements to this new model. I wish we could go back also improve our RAP and HRRR-Smoke models, but this is not easy because those models are frozen. There are no plans to upgrade those models. So it's basically evolution of science and new data set, RAVE data, and all these factors play a role. Yeah. Thank you for pulling this slide. This is a backup slide. So these are variables which are in GRIP2 files to base RFS output. And for example, we have our average now PM 2.5 field now. Before it was just instantaneous, now also our averaged. And HWP or our wildfire potential is in the GRIP2 file. So if anyone is interested, they can pull this data.
Great, thanks for that answer there, Ravan. And we go down to, I believe, Ziwi Dong ask if does the HRRR-Smoke or Rufus fill the gaps missing of FRP, fire radiative power, when there are heavy clouds and smoke blocking satellite detections?
Yeah, good question. So no, we don't fill any gaps. Okay, let me clarify one detail. The RAVE algorithm does some gap filling. So we use the RAVE data. So there is some gap filling going in the this data, RAVE data processing at that stage, but in the model we don't.
Okay. And we also have a question from Yu Zhang asking if RRFS SD data files are publicly available, not just display, question mark. I understand it's still experimental.
The model is experimental, running by NSAP or EMC, but yeah, I put in the chat. So this is all the data is public and available through this Amazon cloud.
Okay. from Brian Curran, Sue down at WFO Midland, land use data. And you can always count on Brian to take us back in geologic time to the Pleistocene pluvial beds across northern Chihuahua, cotton fields across Texas South Plains, etc. might be useful to the models as a source region for dust. Are there plans to incorporate or improve land use data in the RRFS?
Yeah, thank you for excuse me for this question. I think, Brian, actually we use additional data sets like so-called erodibility map to estimate the dust emissions. The dust emissions are based on these soil characteristics and wind speed, soil moisture. So we use this information, but definitely there are a lot of uncertainties. One of the biggest, probably the major uncertainty with respect to the dust forecasting is this agriculture land, cropland. Basically, for example, a farmer goes to the field and plows his land. We don't have that information, but as you know, such this state or the conditions on the on this land can definitely affect. Like yesterday, there was a big dust storm in the state of Washington, which we totally missed it. Simply the model data it doesn't have this information.
Okay, great. Tim Schmidt asked stated great talk, and then good to see that GOES fired data, derived data is getting in. Do you initialize the RRFS SD with any satellite dust level 2 products, such as from the ABI? And then he has a couple of links to some ABI products.
Tim, thank you for the suggestion. Unfortunately, we don't, but this is definitely something we should look into in the future.
Okay, and Corey Anderson asked me to put the last slide up. I think, is that the one we're currently showing? Let's see. Jonathan Case, in the Grid 2 output, why is the smoke and dust assigned an 8-meter height above ground?
Yeah, so we have we display, also provide to the users this so-called near surface smoke and dust fields. What are these fields exactly? These are smoke or dust mass concentrations from the first vertical level of the model grid. And the model grid, the total thickness is about 16 meters, but at the center of that vertical layer, where the model, these concentrations are set. So it's basically how the numerical model is designed. I wouldn't, in the crypto file we have this description 8 meter, but that doesn't mean like we have information, let's say 8 meter, 7 meter. What the model does is uniform, simulates like uniform smoke within this first layer, which goes from the surface to 16 meters. Basically, the idea of that field is that's a smoke, let's say near surface smoke. This is a field, this is areas of concentrations that we humans, breathe, or it affects surface visibility. That's the idea of this field. But if someone is interested in more detailed vertical distribution of smoke or dust, we have that you can get this information by ingesting this 3D model output. I hope the answer is clear, but feel free to.
That makes sense. Thank you, Ravan. That makes sense. I think we do have your previous summary slide back up now for Corey. We've got about 3 more questions here I'd like to get through in the next 2 to 3 minutes before we turn it back over to Jordan. Jarrell Torres asks, are there plans to implement the vertically integrated dust products into AWIPS? I know the vertically integrated smoke and near surface smoke products are currently available in AWIPS and online.
Jorel, great question. The products that you are referring to, which are available, actually are from HRRR-Smoke. I don't think any of the RRFS model output is in AWIPS yet. But again, the data, all the data is in Group 2 files. So I hope this it can be ingested into AWIPS soon.
Yeah, I hope so too. Ziwi Dong said thank you for answering his previous question, and then which paper specifies your algorithm to convert to FRP to emissions?
Oh, yes, I can send you some references. If you share your email, I'm happy to provide that information.
Okay. And then Tom Pierce, are smoke emissions allocated vertically, plume rise?
Yes, we have 5 plume rise. Yeah, I didn't have time to talk about that. Definitely, we have 5 plume rise, and yeah, I can share some examples of that.
Nice. All right. Well, thank you, Ravan, and thanks for the question and answer session here. And with that, I think we'll turn it back over to Jordan.
All right. Thank you so much, Todd. Thanks to everybody for their participation in that discussion. Obviously, this is a hot topic, no pun intended. Thank you so much, Ravan, for that presentation. The Satellite Book Club continues next week in September. Thursday, September 5th, we're pleased to welcome Dr. Mitch Goldberg to talk about the tropics data. Just for some background information, the tropics mission is microwave imagery. So hopefully you'll be interested in checking that out. Also, in the meantime, if you have any questions for our TOWRS team, Kashad and Emily can help with anything related to the book club or the configuration of satellite products in AWIPS. Email addresses are there. You can also find them on the Slack channel Tower-S. So please please find us there and join us next week. With that, I hope everybody has a good weekend, Labor Day weekend when it comes for you. Thanks for those of you that are picking up shifts. We know the Weather Service doesn't stop. And with that, we'll wrap it up for today. Really appreciate it. Thanks again, and take care.